Okay, one more example of this type of math, and in this case, the m is now located here in the b position, and so in our formula that we're about to do, b is m. So again, we're determining the nature of the roots. The answer to this problem is not a value; it's a list of possibilities in the form of a number line. And so we're first going to decide which values in here make this equal to 0. And when I say this, I'm referring to the b squared minus 4ac portion of the quadratic formula. If that's 0, we're going to have one root. Now, again, that's delta, the discriminant. And so if the discriminant is 0, we'll have one root. Let's take our things from our problem and plug them in. And start with the delta equals b squared, which would be m squared, minus 4 times 1 times 3, which is 12. Okay, now this one is going to have two values, and that is because the m is in the b spot. The previous example only had one sort of uh, value in which it's equal to 0. That's what I'm referring to. In this case, there will be two. So we'll solve for m. If we add 12 to both sides, m squared is 12. And then we're going to square root. And if you do it on a calculator, this is probably what you'll get here. Square root of 12 as m. However, there's another answer, and that is because if you take a positive number and square it, you could make 12. If you take a negative number and square it, you could get 12 also. To accommodate that, we put a plus or minus in front of that. Now, square root of 12 is kind of a tricky number. It doesn't come out cleanly, so we can approximate it, or we can reduce it. If you reduce this, it reduces into square root of 4 times square root of 3, which is 2 square root of 3, maintaining the plus or minus. So algebraically, that's the exact answer. Now, that's not very useful for most things. Let's go ahead and approximate it. If we calculate this, and I'm going to go ahead and change the m to be on this side, m is about 3.464. We'll go 3 decimal places. That'll be close enough. Okay, so what that means is that if this value m is 3.464, we will make a parabola with one root. Okay, again, let's organize our thoughts in the form of a number line. And I forgot here, I made the classic mistake, plus or minus that value. Okay, let's not lose track of that. So there are two values, in fact, negative 3.464 and positive the same amount. In either case, and that's for m, by the way, this is m number line. If m is exactly one of those values, then we will get one root or one solution. So there's two values that produce different parabolas consisting of one root. And it'll be something like, in one such case, it might be the parabola in that quadrant, and in the second such case, it might be the one that's in the other quadrant. Making a video. You want to come say hi to everybody? Okay. Now, the question is, what happens in between? If you choose an m value that's in between here, what does that do to your equation? Like supposing, and anything in between here will have the same effect. So let's just test something easy, like if m is 0. So if we test m is 0, and by the way, m squared minus 12, that's our discriminant. What happens? 0 squared minus 12. That is a negative number. Okay, again, doesn't matter that it's 12. It matters that it's negative. And whenever you have a negative underneath the square root, mind you, this comes from the quadratic formula, so let's not lose track of that. If this is negative, then you're not going to have any roots. So we tested 0, but in fact, if we were to test any number in this range between these two magical locations, then oh, hey, Arthur. Oh, okay. Then the same thing will happen, and that is that we will make a parabola with no roots. And so I'm just going to draw a generic one. It doesn't touch there. So if m is between those, and we would write like m is greater than negative 3, 4, 6, 4, or m is less than positive 3, 4, 6, 4, then there will be no roots. Okay, now lastly, what happens on the outside of these is going to be the last possibility. Is that if m is greater than this value, it'll have 2 roots, and likewise over here, I'll write it right here. If it's less than negative 3, 4, 6, 4, it'll have 2 roots. Okay, so the answer for this one is a little more complicated. We've got now, because there were 2 sort of boundaries, we've got 5 different sort of statements to keep track of. And then just to reiterate here, here and here, this would make a parabola with 2 roots, something to that effect.
Yuppie, yuppie.